All right. Now we're going to keep on going. And this is kind of a postulate that will show up later, but this is kind of one of those common sense ones I want you guys to come up with, and I want you to kind of help me figure it out. First of all, we've talked about the word linear, and please understand that hasn't changed from when we talked about collinear points. Remember, collinear points are points on the same line. So anything that's linear, you've got to think line, okay? There's a line involved. And a pair, well, pair means what? Two. So when I talk about a linear pair are two angles that form one line. Okay, let me show the example below. Do you guys see our lovely angle, our line, our straight angle, or line? In this case, I'm going to go line, PR. Okay, and notice I have one single ray coming off. Well, that ray makes this angle and this one. Well, what do I know those two angles have to add up to? Well, we know the whole angle is 180 degrees. So the sum of the parts equal to all means the two smaller ones do that. So when I have a straight angle, then I know the measure of angle PQS plus the measure of angle SQR is equal to 180 degrees. Now, that means they're going to be supplementary. We'll talk more about details, but this is just something you need to know. We use it all year. Two angles form from the same line. Now, I don't mean two angles that look like, here's a line and I have like three angles coming off. These two don't count. It has to be the whole angles that make the line. And this is complicated to understand, and we'll work on it in class to make sure you get it right. But now, just like before, we're going to do our problem-solving process. I always have to ask, what do I have? What is my problem? What diagrams do I have? Where do I want to go? What am I physically solving for? And how am I going to get there? So here's what we have. What do I have? I have the measure of angle XWZ is 121 degrees. I also know the measure, so this is XWZ. The measure of angle XWY is 59. I want to find the measure of angle YWC. So where do I want to go? I want an angle measurement. How am I going to get there? I'm going to mark up my diagram. First of all, they tell me this angle XWZ is 121 degrees. The next thing it does, it tells me angle XWY, so XWY is 59 degrees. I want to find the measure of angle YWZ. Now, I'm going to put an X there because I don't know, I just put my finger on white out there, sorry. I don't know what that is, but do you guys agree with me? The sum of the parts equals the whole. So I'm going to let this be my X. Well, can I go X plus 59 degrees equals 121? Is that one method of how I can get there? Yeah, and if I subtract 59 from both sides, we get 62 degrees. So the measure of angle YWZ is 62 degrees. Now some of you think a little bit differently. Some of you go, well, Mrs. Gregerson, would this be a valid thing to do? Do I have to set up an algebraic equation? Can I just go 121 minus 59 degrees gives me 62 degrees? Yes. How you got there is a little bit different. You still used, basically, believe it or not, we still used the angle addition postulate because we know the two smaller ones add up to the bigger one. You just wrote it in a single step. I just wrote it algebraically. These are both right. How we got there is still good. But you showed me your thinking process and we still got our final answer that we wanted to get. So we know the measure of angle YWZ. Now, we're still going on with more information. So remember, we had a midpoint for a line segment. Remember, a midpoint divides a line segment to two congruent segments. So the angle bisector is like a sister relationship. This time, though, it's a ray that divides an angle into two congruent, and I'm going to use the congruent symbol this time, angles. And that means congruent. I just want you to get used to me putting that in there. Now, here's what I'm talking about. In the diagram below here, in our example, it says ray JK. So I start here, go this direction with the ray. All right, bisects angle LJM. So LJM. If I know it's a bisector, you can automatically assume by its definition and using deductive reasoning that I know these two angles are congruent. And we put the arc marks in for them. In fact, if I ever tell you that something has a midpoint, you put the 2 tick marks. If I ever tell you something's an angle bisector, you automatically mark the angles. If I ever tell you something's perpendicular, you automatically mark the right angles. There's certain things you just automatically do because that's how it helps you solve problems in geometry. So let's go ahead and work a few examples together. And I think you guys are going to do pretty well when we do these. All right, what do I have? What's my problem? Well, the good thing I have a diagram. And I have very specific givens. It says ray KM bisects angle JKL. All right, so this bisects. Keep that information in your head. I know the measure of angle JKM is 4x plus 6 degrees. And I know the measure of angle MKL is 7x minus 12 degrees. Find the measure of angle JKM. So I want to know the measure of this angle. Now, where do I want to go? That is, I want to find the measure of the angle. Now, how in the world am I going to get there? Well, how? In geometry, we know one thing we do is we should mark our diagram, our given up. First, how? Ray KM bisects angle JKL. Can I go ahead and mark that those two are congruent? Let me put it this way. I probably shouldn't give you an option not to mark it. But I'm going to, you should always do it. And then the measure of angle JKM, this one right here, it's 4x plus 6. I'm going to put that in because I know that's the measure of that angle. And my other angle is the measure of angle MKL, that's 7x minus 12. This process now gives me a visual aid. Now, how am I going to get there? I really wish I could write an algebraic equation, right? I need to solve for my variable. Well, how are you going to do it? Oh, I have an angle bisector. Those are congruent. I can set up an equation that lets me solve for it. Isn't that like the coolest thing? Because I know that angle JKM is congruent to angle MKL, so I know that they're going to be equal to each other. And if you wanted to do, and let me tell you something, you do not have to write these 2 steps I just wrote. It's just letting you know the whys behind it. So I'm just going to plug in what I know instead. I got 4x plus 6 is equal to 7x minus 12. Add 12 to both sides. Subtract 4x from both sides. Divide by 3. X is equal to 6. Now I ask myself, where do I want to go? Is that what I want? No. I need to find out the measure of the angle. So we're going to plug it in. So the measure of angle JKM is going to be 4 times 6 plus 6. That's 30 degrees. Does that make sense? All right, make sure, if this is still a struggle for you to come in, the key is going to be marking up your diagrams, making sure things are true, asking ourselves the questions. So let's do another angle bisector type problem, okay? This is ray BD bisects angle ABC. Find the measure of angle ABD and the measure of angle ABC. Now, understand, I know ABD and DBC are congruent, but we're going to get there in a moment. So what do I have? I have an ray bisecting an angle. I have a diagram that illustrates that. Now, where do I want to go? I want the measure of 2 different angles. How am I going to get there? Well, the first how is mark up our given information. I know that these two are the same. And with that, I know I need to solve for the variable or I can't plug something in. Well, the cool thing is, if 2 things are the same, they're what? Congruent. So I can set them equal to each other. So I literally could go 8x minus 28 is equal to 6x minus 6. Flip-flop those around if you want to, whatever works. I'm going to go ahead and subtract. No, let's add 28 to both sides first. Or add 28 to both sides. And I get a positive 22. Now again, some of you need to show this or you get lost in the process. Don't do that. Subtract 6x. Show the work if you need to. 2x is equal to 22. Divide by 2. Divide by 2. X is equal to 11. Now, ask myself again, is that where I want to go? No, I need to plug it in. Well, I'm going to plug it into the first one first because it's a smaller one. So I can say the measure of angle ABD is just 6 times 11 minus 6. Well, that gives it 60 degrees. So the measure of angle ABD is 60 degrees. Now, how am I going to get, now I'm asking myself the question again, ABC? Well, there's two different ways. One way is you could plug it in again for the x here, and you'd realize, oh yeah, I forgot, they're both 60 degrees. And then you'd go 60 plus 60 equals 120. Or could I just say, hey, I just double it because I know they're equal, and I get 120 degrees. To me, that makes the most sense when you're working with it. Okay, let's get the last one down here. I'm going to give you a couple, actually, those were probably some of the best examples, but I'd love to go back to this one because this is a quiz-like question, okay? It says, name the angle at the right in 3 different ways. So just a quick review of what we learned. Remember, you have to name it by a vertex if it's only one angle. So here, that would be angle O. You could also name it by angle 1. You can call it angle MOP, or you can call it angle POM. Those are all the different ways. Now, I could not do angle O here. I can't name angle B. There's too many different angles with angle B down here. So you have to be careful to name it with the middle vertex point in that case. So for instance, it says name all the acute angles. So I want every angle that's going to be less than 90 degrees. Now here's the thing I'd do. I'd actually solve for this real quick first. I know that's 90. That gives me 51 degrees. This is 73. That's 17 degrees. So that's a little bit helpful on that one. All right. So we're working on this one. Let me go through and let's list them real quick. Acute angles. So we have angle ABD. Another acute angle less than 90 degrees is angle DBE. Another acute angle would be angle EBF. So this is the angle, one we're answering. The next one would be angle FBC. And the following one would be these two together, which is 68 degrees, so at angle DBF. So notice I had to name it with the vertex every time and with 3 points because there was more than one angle there. Hopefully this is good enough stuff to get you guys started on this lesson. I know it's a lot of stuff, but lesson 1B is just really taking almost similarities we did with line segments and doing it here. I know regulars, you have honors, you have a lot with this one, but I know you guys can get these and get these well.